the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This, I think, is the 5th video in an introduction to linear algebra. In this series of videos, I'm just going through some quick definitions to remind you, get you up to speed with all your old algebra that's required for linear algebra, and also to kind of talk about how certain aspects of your old algebra, specifically things like solutions, equivalence of systems, that type of thing, ends up being very important for us in linear algebra. In this video, we're going to talk about solutions, specifically how many solutions that systems of linear equations have, and the types of solutions. So we'll start with this theorem. This theorem, actually, I should title as Theorem 1.1.1. Not that you care, but that's just my numbering system. Anyway, a system of linear equations has either no solutions, or exactly one solution, or infinitely many solutions. This, again, should be very familiar to you from your prerequisite algebra course. We will probably prove this later on, but to do the proof, we need some more advanced material. You were not able to prove this back in your algebra courses, and you still can't actually prove it as of this moment. But once we get into the language of matrices and start talking about reduced row echelon form and start talking about free variables, then we can really prove this. It makes it much easier. You can prove this for a 2x2 system very easily, but that's only for a 2x2 system. The big question happens when you say, well, what about 3x3s or 4x4s? Or what if it's not the same number of equations as unknowns? That type of thing. And as far as types of systems that are linked to the solutions here, we have two types: consistent and inconsistent systems. Again, this is a reminder of stuff you learned in the past. A system of equations is called consistent if at least one set of values for the unknowns satisfies each equation in the system. That is, if it has a solution. It could have infinitely many, but at least one solution. That's all I care about. If it has at least one solution, then we call the system consistent. In contrast, a system of equations is called inconsistent if there are no solutions. That's a fast way of saying it. So let's go over to Desmos and create some examples and talk about whether these systems are consistent, whether those systems are inconsistent. Let's take a look at the fact that maybe we can create a system that has no solution, exactly one solution, or infinitely many solutions. And because we're using Desmos, it's only going to be 2x2 systems because Desmos cannot handle 3-dimensional equations at this time.
All right, so here we are within Desmos, and you can see I have two lines graphed right here. Now, you can see that this system of equations, which is a system involving these two lines, has a solution. The solution is, in this case, 2.333 on forever and comma negative 1.333 on forever. So x equals 2 1/3 and y is equal to negative 1 1/3, or negative 4/3 if you prefer that. So this system would be considered consistent. It has one solution. Now, over on the left-hand side, you can see we have a lot of parameters for both systems, or for both equations. The first equation is defined by ax plus by equals c, where a, b, and c are 1 right now. And the second equation is rx plus sy is equal to t, where r is 1, s is 0.1, and t is 2.2. Now I can play around with these, and you can see that we have a single solution for most values in this case, right? And if I continue to play with these, let's say I move this to 2, and let's move this to 2 as well, and let's move this one to 2. Well, once I move that to 2, you could see the black line ends up touching the red line. In this case, both lines overlap each other all the time. In other words, there's an infinite number of places where these lines meet. That is, there's an infinite number of solutions. So we've seen a case where there's a single solution. We've seen a case where there are an infinite number of solutions. And then if I move this value of t, you can see these two are now parallel lines that will never touch. So that's the case where there are no solutions. Remember, if there are solutions, the system is called consistent. If there are no solutions, the system is called inconsistent. And that's what this case is right here. A good visualization using Desmos.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.